హలో. Yeah, hi everyone. We'll wait for few. Before I start, I'm just playing a video. Let's watch.
मर के कैसे जीते हैं इस दुनिया को बतलाने, तेरे लाल चले हैं माए अब तेरी लाज बचाने।
मर के कैसे जीते हैं इस दुनिया को बतलाने, तेरे लाल चले हैं माए अब तेरी लाज बचाने।
आजादी का शोला बन के खून रगों में डोला, मेरा रंग दे मेरा रंग दे बसंती चोला, माए रंग दे मेरा रंग दे बसंती चोला, माए रंग दे मेरा रंग दे बसंती चोला, रंग दे रंग दे रंग दे बसंती चोला, माए रंग दे। दिन आज का बड़ा सुहाना, मौसम भी बड़ा सुनहरा, हम सर पे बांध के आए बलिदानों का ये सहरा।
बेताब हमारे दिल में एक मस्ती सी छाई है देश अलविदा तुझको कहने की घड़ी आई है। महकेंगे तेरी फिजा में हम बन के हवा का झोंका, किस्मत वालों को मिलता
ऐसे मरने का मौका। निकली है बारात, सजा है इनकलाब का डोर,
मेरा रंग दे,
मेरा रंग दे, मेरा रंग दे बसंती चोला रंग दे,
रंग दे, रंग दे बसंती चोला माए रंग दे, मेरा रंग दे बसंती चोला रंग दे,
रंग दे, रंग दे बसंती चोला माए रंग दे।
Only RISC is the only open source architecture we have. So ARM, like earlier we have x86, which is developed by Intel. So if you have a motherboard, let's say if you have a motherboard, the whole motherboard will talk with the main processor, right? Let's say Intel i5 or Intel i6. So the motherboard need to talk with the processor. So that piece of software is called architecture. So that architecture we only have x86, which is developed by Intel, and like lot of people contributed to that, but generally it always the owner of that architecture is Intel. And also we have ARM, which is again the ARM systems is the one who owns it. And in the similar way, there is a complete open source architecture called a RISC. So RISC is again not a some device or something, device or hardware or something. It's basically similar software, just that it is very low level piece of software. So yeah, so and also like there are very like let's see couple of open architecture, right? Open source hardware. So few things are in my mind. There is something called, let me share my screen again. So if you see, this is Bitax. So Bitax is a mining what we call a ASIC miner. So this is complete open source hardware. Again, when we say complete open source hardware, let's do two things right here. There, if you see this particular device, one thing we can see is they're using ESP32, right? ESP32 is, again, we know the major chip is developed by SPIF, and it's not open source. So but how to integrate it? This screen and all, the main PCB and all is again open source. So, and also like if you see under this fan, there is something called BM1366 ASIC. This is major chip that used to do crypto mining. Yeah, so that chip looks like this. And this is not, and again, this is not open source. This is coming from some company. The company name is Antminer. So Antminer develops this particular chip BM1366. So to develop this board, what you need basically a node MCU, or basically this particular chip which is coming from SPRIF systems, and also BM136, which is coming from Antminer. So both of those chips are not open source, but the whole board schematic we can find, right? So if you see here, there is this PCB. Yeah, this SCH file is the main file that is open source. Okay, so okay, this is all about Bitax. Bitax is one such open source hardware. And let's see couple of, I have something called Meshtastic. So I worked on Meshtastic earlier. So if you go to hardware devices, yeah, so Meshtastic is like a radio communication software, which is free for all. Like this whole Meshtastic is open source. And this Meshtastic need couple of devices, right? Couple of boards to work on. It's like a walkie talkie. Consider this Meshtastic is very close to walkie talkie. So if you see here, this Meshtastic firmware installed in any of these systems. We have, yeah, this is one such a board. This board is also similar, like it's using ESP32, and they have like couple of interfaces to it. So similar thing. So freedom box. Yeah. Yeah. So freedom box is sort of software where you can install in a particular device. So that device which you're installing Freedom Box can be called as open hardware. So when we say open hardware, it's not, again, completely not open hardware. Like bits and pieces of it is open. We can just buy those components and build your own self. So this is example of Freedom, build your own Freedom Box. If you see here, yeah. So basically, Freedom Box can be installed. Freedom Box can be installed in any of the systems. So all of these are like open hardware. Let's say, like in case of Raspberry Pi, let's see Raspberry Pi, right? Yeah. So in Raspberry Pi, the main chip, this is main chip, which is like a main like i6 Intel i6 processor. So the main processor is coming from Broadcom, and we don't know like what is how this Broadcom chip is designed. In the same way, there are few chips related to GPU. There are GPU chips and there are Wi-Fi chips on Raspberry Pi. So those are like not completely open source. But let's see these interfaces you are seeing, right? How they are integrating these registers and everything with these chips. That part is open source. So that's why like that's why like people there is a war, like from there is sort of ask or war from open community that why can't Broadcom release their the chip, the main chip that we are using in the Raspberry Pi, why can't they release that schematic online, right? We know that even though release that chip, we can't do anything about it, right? Even when I had schematic of this particular Broadcom chip with me, the entire schematic, can I go and build this chip my own? No, right? We can't build, because like I already told you, like that is $1 billion industry to just manufacture the chip. It needs a separate process. So again, our entire India doesn't have the capability as of today to only the mass production of chips is happening in Taiwan and China. So we can't even build the chip by our own. So, but why people are asking to just line, then as of today, we don't have that chip, but in future, we might have a semiconductor industry in Andhra Pradesh, right? So if we have the schematic, we go and print it. So that's the idea. But the problem here is this Broadcom chip is not only used in Raspberry Pi. Broadcom is a company, and the chip uh, Raspberry Pi using Broadcom processor. That's it. But Broadcom will use this chip in phones and lot of other things. So why will they give their schematic? Why Broadcom will give their process schematic to the open source community? Right? Raspberry Pi can give their schematic because like their philosophy is different, but they're using Broadcom chip, and we cannot ask Broadcom to open source it. So that is the major reason. So if you take any single chip, it's not on its application is not on Raspberry Pi. It used in other places. Let's say it can be that same chip can be used in some of the security, very secure devices. Maybe in war missions, or like in tanks, or in drones, military drones and all. So they cannot completely reveal that entire schematic to the public. So that is one reason we had this sort of not complete open software in the like in the world, right? Yeah. So anybody have any questions, like, or you want to share anything on open hardware, like, or what are your thoughts so far? Like, do you think an open hardware is complete like a open source software till now, and now your perspective change it, something like that? I don't think I'm not getting any reply from any of you, so I don't understand if you're getting what I'm saying. Yeah, somebody is typing. And also like Arduino also, if you see, let's go to the Arduino chip. Yeah, if you see the image, everything in the Arduino image is like open source. We all know like what type of crystal oscillator they are using, and how these digital pins are manufactured. Whole board schematic is available. Just that if you see this major black bar, right, this is the main microcontroller, which is brain of Arduino. That is actually a separate piece of software. It is actually designed by Atmel. So there is a company called, yeah. So there is a company called Atmel. So Atmel Corporation. So this company basically designed that particular if you see zoom this one, if you see the number is like 328p or something, or even if I found it here, right? So this is the one. At Mega 328p. At Mega 328p is the major chip, and you can buy it. And also, if you see the format is again like that Mega chip we are talking here is again available in different formats. We have seen it in the straight chip like this configuration on Arduino, or like a this is called SMD chip or something. So it is available in this format, or this is available in this format too, right? So there are different types of PCBs available. uh, Let me show you. So when the component has pins like this, it that type of PCB where you use soldering iron and then solder, right? That is called SMD components. Uh, this is the and if you see the configuration in the this is when you have the pins like this is SMD pin where you can use SMD PCB to use this, and this is more like your traditional PCB. I will show you that too. Yeah, this one. You can just use this type of PCB and use this type of package to yeah, so basically to integrate to this particular PCB. Yeah, so there are like it's available in different formats, and this is completely if you see like a PCB where you cannot touch it, like even you can't solder it, right? So this is directly manufactured at the board level, and they use what we call a different soldering mechanism. So this is that type of packaging. So there are different packagings available for the same chip. Okay, yeah. So let's see what people are typing. Yeah. Yeah. So yeah, correct. So hardware has certain standards that they adhere to. Let me see what's. But majorly, the open when we say open hardware, I just want to think it like this. Open hardware is not like a open source software where if you take your open source software, you can just take the software and just use it in your laptop, and you can change any part of the open software and use it in your laptop. But in open hardware, you can buy the individual components. You can buy individual components and then use those individual components to build your own hardware. But you cannot avoid buying individual components. Okay, so you need to buy individual components and build your own hardware, but you cannot make your own individual components. Those individual components can be proprietary, right? So that is all about open hardware. Okay, so uh, this is very high level introduction we want to take for every one of you. So what is open hardware, since this is Arduino day and all. Okay, so and the second part, like coming to the what we're trying to do is we are trying to do a podcast on a bi-weekly basis, I am thinking initially. So basically anyone, we create a group, we create a Telegram group, and all the like-minded people can come into that group. Okay, so in that group, what we will do is we will just put an Excel sheet every bi-weekly basis, and you can put your own topic there. Let's say you want to talk about 3D printer, and you know how to how to use 3D printer, or how to build something using 3D printer. So that can be a topic for that week. So basically you can come into podcast as a presenter, or there can be like couple of audience who asks you question, but it is complete interactive. It can, video is mandatory, audio is mandatory, camera is mandatory, everyone is interactive in that section. So they will ask you bunch of questions like how to do this, how to do that. If you are presenting a 3D printer, like how can I use, which software I can use through 3D printer, or maybe we can just demo couple of 3D printing things and all. That can be a topic. Or there can be another topic, let's say drone. Somebody is making a drone, they can come and show us how to make a drone. So basically, not so basically we are targeting more like a hardware part, like somebody is building something in a hardware, or like they can be both software or hardware combined. But let's say a product, majorly a product uh, which is like a little bit technical, and we don't go non-technical topics. We don't take non-technical topics in the podcast, mostly technical topics. You can take any technical topic mostly, and then the technical topic should involve little bit of hardware or little bit of software, and we can then talk about in the podcast. So that is the idea behind the podcast. So mostly we'll create the group and circulate it around Telegram group and circulate it around, so people can join in that groups. And bi-weekly basis we get a basically a spreadsheet or Excel sheet. Who any people who are doing some interesting stuff, any new project or any hardware, need to fill that Excel sheet, and also the time, how much time they're gonna talk about it. And people can vote. People can vote which topic they are interested in. Let's say there are 10 topics for that week. We will vote for a particular topic, and then we choose that topic for that week. So that's how it goes. So we are calling it as e-wide, so, SwechaAP. So we can we did not yet decided whether it's going to be live session into YouTube, or live session into YouTube, or record it first and do the editing next and put it in YouTube. But idea is to put in YouTube. That's the basic goal. Yeah. Anything else? Anyone have any doubts? Somebody is telling open hardware. I don't think open hardware is proprietary. For something to be considered open hardware, that specific component should be open enough for any other company to reproduce without any license or artificial restrictions. Yep, but uh, I agree partially that that is correct, but there is no such open hardware, let's say, is Arduino is considered open source. If we are agreeing, let's say Arduino is open source, can you build your own Arduino at home without buying anything? Then why we are considering it as open hardware? The major microcontroller inside the Arduino is Atmega, which is again proprietary. Then why we are consider Arduino open hardware? So please think about it.